All right, everybody, welcome back. This is part two of chapter two of the OpenStax online psychology textbook. My name is Prescott, and I'm here with Succinct Psychology, and I will be going through part two of here, or part two here. Today we'll be finishing up chapter two. It's a bit of a shorter chapter. And so last time we went over different types of research, naturalistic observation, clinical or case studies. So we're going to continue that today. And last time we went over a little bit correlational research, what correlation is, coefficients, positive, negative, all that good stuff. So now we're going to continue talking about correlation with correlation does not indicate causation. So a cause and effect relationship are changes in one variable, or when changes in one variable cause the changes in the other variable, and can be determined only through through an experimental research design. So you can't prove a cause and effect relationship with a correlational research. So, height going up and weight going up, there might be a correlation there, but that doesn't mean that the taller you are, the heavier you are. There's no cause and effect there. You can't prove that with correlational research. So, and then with cause and effect relationships, we have a confounding variable, an unanticipated outside factor that affects both variables of interest, often giving the false impression that changes in one variable causes changes in the other variable. So that, again, that's the unanticipated outside factor that does affect both variables, and it might give the false impression that one variable causes the change in the other, even though there's a third variable that they just weren't aware of, the researchers. So for example, as ice cream sales increase, so does the overall rate in crime. So a relationship exists between ice cream and crime, but is it a correlation or does one cause the other? In this example, temperature is a confounding variable, so temperature was the variable that they weren't factoring. As the temperature increases, ice cream sales increase and people are more likely to be outside, increasing crime rates. So there's a relationship, but the temperature was the confounding variable, which was causing the relationship between the two. So going on, does eating cereal really cause someone to be a healthy weight? So again, I want you guys to think about, does eating cereal cause you to be a healthy weight, or is there a confounding variable? Is there a third variable that's leading to people that eat cereal to be a healthy weight? Illusory correlations. As well as mistaking correlation for causation, people can make false correlations. So an illusory correlation is seeing relationships between two things when in reality, no such relationship exists. And confirmation bias is the tendency to ignore evidence that disproves ideas or beliefs. So illusory correlations can be evolved in the formation of prejudicial, I think I'm saying that right, attitudes that can lead to discriminatory behavior. Many people believe that a full moon makes people behave oddly. Research demonstrates that this relationship does not exist. So I think of illusory correlations as kind of like conspiracy theories. If you look at any conspiracy theories, people will see relationships between two things, because there's a coincidence here, but there's no relationship, but they just see this imaginary relationship between the two things. And then confirmation bias is, you're doing research on something and you want to prove a point, and so you find one piece of evidence that supports your point. You're like, aha, I was right, even though there's a bunch of evidence that is saying, no, you're wrong. But you're looking for that one bit of evidence that proves your point. That's confirmation bias. Causality, conducting experiments and using the data. The only way to establish that there is a cause and effect relationship between two variables is to conduct a scientific experiment. A scientific experiment has precise requirements for design and implementation. So, starting off, we have the experimental hypotheses. Hypotheses can be formulated through observation or after review of previous research. So going on, we have designing an experiment. So we have experimental and control groups. An experimental group is when the participants that experience the manipulated variable or are the participants that experience the manipulated variable. So the group designed to answer the research question. Then you have a control group and participants that do not experience the manipulated variable. So that's your control group. They're controlling it. They're not the experimental. They do not receive the manipulated variable. So control groups serve as a basis for comparison and controls for chance factors that might influence the rest of the study. Experimental manipulation is the only difference between the experimental and control groups, so any differences between the two are due to experimental manipulation rather than chance. So defining variables and how they will be measured. So you need an operational definition to define variables, which is a description of what actions and operations will be used to measure the dependent variables and manipulate the independent variables. So there you go, that's your operational definition. And operational definition is also defining in terms of your study, like, for example, so if you're doing a study on anxiety in teenagers, you need to have an operational definition of how you're going to measure anxiety. What is anxiety in the study? Like you need to have a definition of that term in order to effectively conduct your experiment. So continuing on with designing an experiment, we have avoiding bias and the placebo effect. So experimenter bias is when researcher expectations skew the results of the study, and then participant bias is participant expectations skew the results of the study. So pretty self-explanatory. So researcher expects to get certain results, and once they get all the results in, their expectations can skew the results. And same thing for participant bias. So to avoid this, we have a single blind study, in which an experiment in which the researcher knows which participants are in the experimental group and which are in the control group, but participants do not. So it controls for participant expectations, it removes this problem. Then we have a double-blind study, which is an experiment in which both the researchers and the participants are blind to group assignments. So it controls for both participant bias and experimenter bias, or expectations. Then we have the placebo effect, which is people's expectations or beliefs influencing or determining their experience in a given situation. So this happens when people are given a pill to improve their mood, their mood may increase just because they believe it will. Or to know if a medication is really having an effect, or whether there's a typo there, the placebo effect, the experimental group receive the medication and the control group receive a placebo treatment or a sugar pill. This is a double-blind study. Any differences between the groups will be due to medication. So to avoid the placebo effect, you can't tell somebody, even if it's a sugar pill, that, this is this drug, because you have the potential for the participants, and this happened in numerous studies, convince themselves that they're under the influence of the drug or experiencing what the experimental group is actually experiencing, but their brain's just tricking them into thinking it. Here we have a figure providing the control group with a placebo treatment protects against bias caused by expectancy. There you go. So next we go on to variables. So an independent variable is a variable that is influenced/controlled by the experimenter. Ideally, this should be the only important difference between the experimental and control group. And then you have a dependent variable, which is a variable that the researcher measures to see how much effect the independent variable had. Here we have an example. So the independent variable is the type of television program viewed. So here we have, looks like Rambo shooting a machine gun. Oh, whoops, I did not mean to go down. Which the independent variable influence change in the dependent variable, which is the violent behavior displayed from children watching a violent program. So see, there we go, more in detail down there at the bottom. All right, so how do researchers go about selecting participants for their studies? So, definition of participants are subjects of psychological research. So populations are too large for a researcher to include everyone, so you have to use a sample. So a sample is a subset of individuals selected from the larger population, and a population is the overall group of individuals that the researcher is interested in, e.g. college students. Now, a random sample is a subset of a larger population in which every member of the population has an equal chance of being selected. This form of sampling is preferred because it's more likely that selected participants will be representative of the larger population. So sex, ethnicity, social economic status, etc., etc. So here we have a little figure. Researchers may work with A, a large population, or B, a sample group that is a subset of the larger population. So that's how researchers select the participants. So now, assigning participants to groups, experimental or control. So random assignment is a method of experimental group assignment in which all participants have an equal chance of being assigned to either group. This can be achieved using statistical software or by simply flipping a coin. And it prevents systematic differences between groups such as gender or age. Without random assignment, an experiment cannot find a true cause and effect relationship. Any relationship could be due to pre-existing differences between the groups. Random assignment helps to avoid pre-existing systematic differences so that any significant differences between groups can be said to be the result of the manipulation. So, again, I can't really talk too much about this because it goes pretty in-depth and explains what exactly random assignment is. Now, there's some issues to consider. First off, we have manipulating variables. As stated, random assignment is required to state causation. Once randomly assigned, each group is then manipulated in some way. However, some experimental designs are more complicated. So an example is the effect of sex, male/female, on spatial memory. So sex is your independent variable and it cannot be manipulated. So males and females cannot be randomly assigned. This kind of an experiment is therefore called quasi-experimental or almost experimental. A cause and effect relationship cannot be determined from a quasi-experimental experiment. And then you have to consider ethics. Some questions cannot be answered using experimental design because they would be unethical. So example, the effect of experiencing abuse as a child on levels of self-esteem. So obviously you cannot randomly assign participants to receive abuse because that's unethical. So this would need to be studied using other approaches such as case studies or surveys. You can't go and beat up a kid for a study. So interpreting experimental findings. Once data has been collected, a statistical analysis is conducted. So a statistical analysis determines how likely any difference between experimental groups is due to chance. So psychologists usually discuss results as significant or non-significant. If the odds that the differences occurred by a chance are 5% or less, then the results are significant. So a true experiment, including random assignment, manipulation of an independent variable, and control of extraneous variables, reduce the odds of results occurring by chance. So actually, I was going to finish this up, but I don't want to keep you guys for too long. So we only have a couple more slides, and next video will be a short one, but I'll just go through those in the next video. Again, my name is Prescott. I'm here with Psychcinct Psychology, and I hope you guys have a great day, and I will see you next video.